point, and then dy equals mx plus c. So when we differentiate the 2, that's going to disappear and just be 0. So we don't need to worry about that. To differentiate the ln of 1 plus 4x, we've got the 1 plus 4x that is inside the logarithm. So differentiate the logarithm first, and we get 1 over the function, 1 over the 1 plus 4x. And then we're going to multiply that by the derivative of the inside function. The derivative of the 1 plus 4x is just 4. So my gradient function then is just simply 4 over 1 plus 4x. Now, at the point when x equals 0, I can substitute that into my gradient function. So I'll get 4 plus 1 over 4 times 0, which is 4 over 1, or just 4. So that's the gradient of the tangent at x equals 0. So I can now say y equals 4x plus c. Now I need to know a coordinate to substitute in here to work out what my c is. Now I know that the x coordinate is 0 here, so if I substitute 0 into my y function, so substitute 0 in here, I find that y is equal to 2 plus ln 1, which is just 2. So if I substitute the coordinate 0, 2 down here, I find that the c-intercept is just 2, and therefore the equation of the tangent is y equals 4x plus 2. Right, this second function. Same idea, we want the tangent to y equals 9 over x squared plus 2 at the point when x is equal to 1. First thing I'm going to do, in order for me to differentiate this, is I need to write it in a form that can be differentiated. So I'm going to take that x squared plus 2 that's on the denominator, and I'm going to move it up to be on the numerator with a negative power. Now I can differentiate this because I have got the x squared plus 2 inside the power minus 1. So let's differentiate the power of the minus 1 first. So times by minus 1. Take 1 away from the power. And then by the chain rule, we're going to multiply that by the derivative of the inside function. The derivative of x squared plus 2 is 2x. So that's then going to simplify. The minus 9 times the 2x is minus 18x. And I'm just going to take that x squared plus 2 and put that back on the denominator with the 2 power. So that's my gradient function. And I want to find the tangent when x is 1. So let's substitute that into my gradient function to work out the gradient of the tangent. So we'll have minus 18 times 1 divided by 1 squared plus 2 all squared. So that's minus 18 over 3 squared, which is minus 2. So the gradient of the tangent is minus 2 when x is 1. And right, we now need the coordinates to substitute into this. So let's take our 1 and substitute it into this original function to get the y coordinate. So 1 squared is 1, add the 2 is 3, and 9 divided by the 3 is 3. Let's substitute that into my function here. And I find that c is 5. So therefore the equation of the tangent is y equals minus 2x plus 5, And that's that.